Okay, in previous section, while describing, exploring, and comparing data, we discussed about statistics like mean, median, mode, range, standard deviation to describe the data, and then in this section, we're going to measure of relative standing, and then we're going to use Boxplot to represent the data. Okay, so. So one of the very important concept we're going to discuss here is called z-score. It's a number which is very useful. And then also we're going to discuss about percentile and quartiles. And then finally we're going to construct a box plot. So a z-score is the number of standard deviation that a given value x is above or below the mean. If you are playing with the population, this is the formula we're going to use, and if we have sample, then this is the formula we are going to use. So as you can see that if you just multiply both sides by this standard deviation, this is z-score times standard deviation is x minus x bar. So you can see that z-score represents how let's say z-score is 3, then you can see that the difference between the data, which is x, from the mean is 3 times the standard deviation. So z-score represents a number which tells us how much that data is differ from the standard deviation, or differ from the average or mean. Okay, so these are the formula we're going to use to calculate the z-score. So it's very useful formula. So we always try to round the z-score into 2 decimal places unless we have instructed in a different ways. So some of the properties for the z-score. Z-score is the number of standard deviation that a given value x is above or below the mean. That's what we discussed. It doesn't have any units, so it's just a number, no unit. If your z-score is less than -2, then the data value is significantly low. If the z-score is greater than +2, then that data value has significantly high. And if an individual data value is less than the mean, its corresponding z-score is negative. And if the individual data value is more than the mean, then its corresponding z-score should be positive. Let's look at 2 examples here. The first one, 99 Fahrenheit temperature of an adult among 106 adult, which is sample, and then average is given, the mean is given 98.2 Fahrenheit, and sample standard deviation is 0.62. And in second example, 5.7790 gram weight of a quarter among 40 quarters with the sample mean 5.63930 gram and sample standard deviation 0.06194. So we need to compare these 2 data. Which of the following 2 data value is more extreme? We need to, so keep in mind these are the completely different type of data, different size, but still we can compare them by using their z-score. So we can compare 2 different set of the data by using their z-score. That's the beauty of z-score. Let's try to calculate the z-score for each of these information. If you try to find the z-score for the first one, it gives you 1.29 by using the formula x minus x bar over s. Just plug the value, use a calculator, and it gives you 1.29. By doing the same thing for the second set of the data, it is 2.26. So as you can see that 2.26 and 1.29, anything greater than 2 is significantly high, anything less than 2 is significantly low. So by just looking this to data set, we can to this to z-score, we can say that the z-score show that 99 Fahrenheit body temperature is 1.29 and 1.29 is standard deviation above the mean, and then 5.7790 gram weight of the quarter is 2.26 standard deviation above the mean. Because the weight of the quarter is farther above the mean, it is the more extreme value. More extreme means it's highly unlikely. You know, the chance is very low. So weight of 5.7790 gram of a quarter is more extreme than a 99 degree Fahrenheit body temperature. That's extreme means, if you are looking for the probability, you can say that it's less chance. So we always have to keep in mind something. If you find the g-score less than -2, then the value, that data value has very significantly low values. Anything greater than 2, significantly high values. Those are the extreme value. And something, if g-score is from -2 to +2, then value is not significant, not extreme. Okay, let's look at one more example here. Among the earthquake given, so we have given this information already. One of the stronger earthquake had a magnitude of 4.01. So this is the magnitude we have given. The magnitudes are measured on the Richter scale. That's the unit of the magnitude. And only earthquake of magnitude 1.00 or higher are included. That's the given information. The 600 magnitude in the data set have a mean of 2.572. That's the mean. And the standard deviation is given, which is 0.651. Now, for this data set, is the magnitude of 4.01 significantly high? That's the information we need to find out. Is 4.01 is significantly high? Is the chance of happening this magnitude of earthquake is extreme? That's what we need to answer. For that, we can calculate the g-score. So as you can see that g-score is equal to data value minus data value minus as you plug the value of x bar s, you can find out the g-score is 2.21. It means having this magnitude 4.01 is significantly high, because of this thing. Something that if the g-score is greater than 2, that means that value is significantly high values. Okay, now the next topic is percentile. Percentiles are measures of location. So if you have data, you want to sort the data and you want to find out the percentile. We denote percentile by using this notation P1, P2, P3, P4 up to P99. We divide a set of data into 100 groups with about 1% of the above in each group. The good thing about this percentile is this percentile will divide your data into different percentages. For example, if you find P5, then anything less than P5, there is a 5% of the data less than P5 and 95% of the data greater than P5. That's how you can divide your data. That's why percentile are very useful. If you want to find out the percentile for a data value, then we can use this formula. Percentile for any data value can be found by using this formula, which is that data value divided by total number of values times 100. That gives you the percentile for any data value. Let's look at one example. The table here given, it's a 50 list of the data of Space Mountain, 10 a.m. wait time. So these are the wait times from Disney World wait times, arranged in increasing order. So they are already sorted. Find the percentile for the wait time of 45 minutes. So as you can see here, the 45 minutes is here, which is there are 10 data, 10, 20, 30, 31, 32, 33, 34, 35, 36, 37. So there are 36 data less than 45. So we can find the percentile of 45 by using the formula. This is the formula. Number of values less than 45 divided by total number of values times 100. So number of values less than 45 are 36 divided by total number of data times 100. That gives you 72. So the percentile for 45 is 72. So the interpretation of this information is A wait time of 45 minutes is in the 72nd percentile. This can be interpreted loosely as this. A wait time of 45 minutes separates the lowest 72% of the values from the highest 28% of the values. So if you look at the data here, there are 72% data which is lower than 45, and there are 28% data which is higher than 45. That's the meaning of percentile. So notation we have to keep in mind in this case is n is the total number of values, k is the percentile being used. Example, for the 25th percentile, k is 25. L is the locator that gives the position of the value. We are planning to find out the value of pk, means percentile. Like if you want to find out p1 or p2 or p50, first of all, to find this thing we need to find the locator L. And to find the locator L, these are the notation we are going to use. N stands for total number of data and k stands for percentage being used. I'm going to give you an example here. But before that, whenever you try to find out the percentile, start your data. First of all, you need to sort the data. Arrange the data in order of lowest to highest. And then after that, you have to find out the locator L. As you can see here, L stands for the locator, which can be computed by using this formula k over 100 times n. And where n is the number of values, k is the percentile in question. So for example, if you want to find out the p50, then to find that p50, you need to find the locator L, which is 50 divided by 100 times the total number of data. N is number of values. Okay. So that's how you find the locator. After finding the locator, based on your value of the locator, if L is whole number, then you can find the percentile, meaning pk, or in this case p50, by finding the average of that locator, the data from that locator and the next value. So find pk by adding the lth value and the next value and dividing by 2. That is the average. Okay. If L is the whole number, then we need to go to the data set. We need to find the data from that L number and the next number. And we need to find out the average of those two numbers. If L is not the whole number, it's a decimal number, then round that locator to the next whole number and then pick the data from that position, and that will give you the pk. That means percentile. Pk percentile, kth percentile. I'm going to show you one example here. So let's go to example. Let's say this is the data you have given, the same data. Initially it's not sorted, so you need to it's already sorted, 10, 15, 15, 15, so it's already sorted. And our goal is to find out the p25. So according to the formula, if you use the formula, what is that? This is the formula. First of all, you need to find the locator. According to this, you need to find the locator, which is k over 100 times n. In this case, k is 25. So it's k over 100 means 25 over 100 times 50, because there are 50 datas. If you calculate this, it will give you 12.5. Because it's a decimal number, you have to round it to the next whole number, which is 13. And you go back to this data and then you find the data from the 13th position. Meaning there are 10 data, 11, 12, 13. So this is the data we are looking for. That's 25. So since L is 12.5 is not a whole number, we proceed to the next lower box in the figure, meaning here. And then we round it to the next whole number, which is 13. From the bottom box, we see that the value of P25 is 13th value, counting from the lowest. So that is 25. Make sense? That's how we can find out the locator. Percentile, by finding the locator. Now, after finding the percentile, there are three numbers. They are very important. They are called quartiles. Meaning, you have the data set. You can divide this data using three numbers, and they are called quartiles. First quartile means data 25% of the data value are less than that number. Second quartile means 50% of data value less than that number. Okay, so third quartile, it means 75% of the data value less than that number. That's how we can divide data using quartiles. So Q1 first quartile, same value as P25. Q2 second quartile, same value as P50, percentile 50, and Q3 same as P75. So there is one thing I would like to caution here. Make sure that we use different type of method or technology for finding the percentile. So there is no universal agreement. Okay. So some of the information, difference between Q3 and Q1, it's called interquartile range. Semi-quartile range means if you divide that number by 2. Mid-quartile is Q3 plus Q1 divided by 2, and 10 to 90 percentile range can be found by finding the difference between P90 and then P10. So by using this quartile Q1, Q2, Q3, we can describe the data using 5-number summary. So meaning you have given a data set is going from minimum value to maximum value, and then we can use those 3 quartile Q1, Q2, Q3 as well. So these 5 number are called 5-number summary for the data. For example, let's say this is the same data we used previously, and sorted data, it's already sorted, so we know the minimum value is 10, maximum value is 110, and then we can find quartile 1, quartile 2, quartile 3. So here quartile 1 is 25, quartile 2 is the median is equal to Q2 and it is 35 minutes, because as you can see that both of these values are equal, so average of 35 and 35 is 35, and Q3 is 50. So 5-number summary are these numbers: minimum value, maximum value, Q1, Q2, Q3. Okay, by using this 5-number summary, we can draw a graphical representation for the data. That's called box plot. Okay, so how to construct a box plot? First of all, you need to find out the 5-number summary, and you need to construct a line segment extending from the minimum data value to the maximum data value. Construct a box extending from Q1 to Q3, and draw a line in the box at the value of Q2. Meaning, in these data sets, we can find the minimum and the maximum value, Q1, Q2, Q3. So you start from here, you go up to here, you start constructing a box from Q1 to Q3, and you draw a line for Q2. This is called box plot. Okay. By using the box plot, we can find out skewness of the data. So as you can see here, these are the 3 examples. As you can see here, this is a right skew data. This is a normal distribution, and this is the uniform distribution. Just by looking the box plot, we can find out this distribution. Okay. So identify outlier for modified box plots. Sometime we can identify outliers, for the modified box plot. First of all, to do that, you need to find out the Q1, Q2, Q3. You need to find out the IQR, which is interquartile range, which is the difference between Q3 and Q1. And you need to just multiply this value by 1.5. In a modified box plot, data value is an outlier if it is above Q3 by an amount greater than 1.5 times IQR. So we can use the modified box plots to find out the outlier, and this is the process to find out the outlier. So anything below 1.5 times IQR is and then anything above Q3 than 1.5 of IQR, they are called outlier. Okay. So modified box plot. A modified box plot is a regular box plot constructed with this modification. A special symbol such as an asterisk or point is used to identify outlier as defined above. So these are the method for finding the outlier, and we can use this asterisk sign for to denote the outlier. The solid horizontal line extends only as far as the minimum data value that is not an outlier and the maximum data value that is not an outlier. So this is how we can find out the box plot. So but mainly in this section you have to focus on G-score, you have to focus on percentile, you have to focus on let's say quartiles, you need to focus on 5-number summary, and then a box plot. So these are the things you have to focus on in this section. So let's look at some of the examples from your homework section, from this section. So let's do first problem here. A successful basketball player has a height of 6 feet 11 inches, which is 211 centimeter. Based on statistics from a dataset, his height converts to the G-score 5.17. That's the G-score. How many standard deviation in his height above the mean? So as you know that the G-score, if you go back to the G-score definition, G-score is the number of standard deviation that a given value x is above or below the mean. So but just by looking at the G-score, you can say that how much that's differ from the mean. So here the G-score is 5.17. The player's height is round to the 2 decimal place, 5.17 standard deviation. So that's a G-score, 5.17 standard deviation above the mean. Because as you can see that the difference between the data and the mean is G-score times the standard deviation. So in this case it's a G-score is 5.17, so it's a 5.17 standard deviation above the mean. Let's look at another example. So hopefully you can see this here. In designing a work desk, it is found that males have sitting knee heights with a mean of 21.6 inch and a standard deviation of 2.2 inch based on the data from the Department of Transportation. Use the range rule of thumb to identify A, the value that are significantly low, B, the value that are significantly high, and then C, the value that are neither significantly low nor high. So for finding this information, so let's go back here. So for finding this information, let's go back to that significance rule chart here. If your G-score is greater than 2, that means significantly high. If G-score is less than -2, that is significantly low. Anything in between them is values is not significant. So to answer the first question, what heights are significantly low, you need to assume that your G-score is -2, and then using this information given here, you can find out the height. So let's say, let me just use blank page here. So in this case, what heights are significantly low? So when G-score is -2 or less, we assume that that height is significantly low. So we know the G-score is actually difference between the data minus the mean over standard deviation. So we would like to find out the height, which is the value of x, such that G-score is significantly low, that data is significantly low. So Z is -2. We don't know the data. The mean is given, it's what is that, 21.6, and then the standard deviation is 2.2. Plug this value, just multiply both sides by 2.2. So that is 2.2 times -2 times 2.2 equal x minus 21.6. And if you try to solve this, just multiply this and add 21.6 both sides. So -2 times 2.2 plus 21.6 equal x. So anything less than this data value is called significantly low. So to calculate this, I'm going to use my calculator here. Let's say Okay, so I'm going to calculate this 21.6 plus parenthesis negative 2 times 2.2, that is okay, it's 21.6 plus, inside the parenthesis negative sign, I have to use this one, that's why I got the error there, 2 times 2.2 parenthesis close, that is 17.2. so anything less than 17.2 height that are less than 17.2 inches is significantly low. Okay, for the second part you do the same thing, but instead of g-score -2 you use +2. Okay, so instead of -2 that will be positive, so I'm going to change this negative by positive, because anything, if the g-score is greater than 2, we say that data value is significantly high, so I'm going to use this plus, and I'm going to calculate the very same thing using the calculator here. It's a 21.6 plus, inside the parentheses it's this time +2 times 2.2. so anything greater than 26 is called significantly high. That's significantly high. And in between these two data sets, that's called neither significantly low nor significantly high. So we need to choose this option, anything greater than 26 and less than 17.2. What did I do wrong here? Heights that are greater than, okay, sorry, I have to switch it. It's greater than 17.2 and less than 26. Okay, we have to switch it. That's it, significantly low. Okay, according to this, if you go back to this thing, what is that? Yeah, this one. Anything less than when g-score is -2 is significantly low. Anything greater than when g-score is greater than 2 is significantly high. In between these two values, which is between 17.2 and 26, that's neither significantly low nor significantly high. Let's do another problem. Use the given data here, which is for radiation level, which is in watt per kg for 50 different cell phone. Find the P30, that means percentile 30. So first of all, you can copy this data in StatCrunch, and you can sort this data by going here, data, sort the first column, which is variable 1, sort variable 1, and if you compute it, this data is already sorted here. We would like to find out the P30. So if you go back here and check your formula for P30, so this is the formula for finding percentile. You need to find out the locator. Locator means L, which is K over 100 times N. K means it's a percentile in question. So we need to find out P30 in this problem. So K is 30. So the locator is 30 divided by 100 times total number of data. In this case, there are 50 data. As you can see here, there are 50 data. So by doing this calculation, it would be 15. So 15 is the whole number. Then if locator is the whole number, then you need to find out the data from 50th position and 16th position. Where is that? 15th position is 0.93, 16th position is also 0.93. So average of these two number is 0.93. So percentile P30 is 0.93. Okay, let's go to the next problem. Fill in the blank. A data value is considered dash if g-score is less than -2 or greater than +2. So that means it's an option you have given, significantly low or significantly high, if its g-score is less than -2 or greater than 2. Finally, let's look at last problem. Which of the following not a value in 5-number summary? Remember, in 5-number summary you have minimum value, maximum value, quartile 1, quartile 2, quartile 3. Quartile 2 means median, Q1 is quartile 1, mean is not in 5-number summary. Okay, so that's our measures of relative standing and box plot.